Okay, now let's look at this statement. This question. So this question came basically in Gate 2015, and the question is something like this: in a connected graph, a bridge is an edge whose removal disconnects a graph. Which one of the following statements is true? So first statement is saying that a tree has no bridges. So let's consider any tree. So let's say this is some tree, and a tree has no bridges. And bridge is what? Bridge is an edge whose removal disconnects the graph. Is there any edge which if I remove, then the graph becomes disconnected? In fact, by definition of a tree, if in a tree every edge is a bridge. You try to remove any edge, it will disconnect the graph. Why? Because the minimum number of edges which is needed in order to connect n vertices is n minus 1, and that is n minus 1 is the total number of edges which are there in a graph, in a tree, and that's why it is always going to disconnect. So this statement is definitely false. Any edge you remove, the graph becomes disconnected. Okay, so this statement is false. A bridge cannot be part of a simple cycle. Now this looks correct. Okay, so there is any cycle, and they are saying that if it is a cycle, then it cannot have a bridge. That is true, because see, the cycle is basically saying that okay, I am having one extra edge, and any edge you remove, I am still connected. Why? Because cycle is simply saying that okay, from here I can go to here by two ways. One is this path, one is this path. If you disconnect me, then I will lose one path, but I will still be able to go via another path. So the entire thing will be still connected. Okay. So by that definition, a bridge cannot be part of a simple cycle. So this statement looks correct, definitely. Now if that is correct, then the third and the fourth statement have to be wrong. Now how can that happen? See, if every edge of a click with size greater than or equal to 3 is a bridge, is it possible? See, we try to create a bridge with we try to create a 3 click. So a click with three elements. So click is basically a complete subgraph. So trivially a complete graph is also a click. So with 3 vertices, the complete graph is this. This is a click, right? Now every edge of a click is a bridge. Now you can see that that is wrong, right? Because see, in this case you remove this thing and it is still connected. So it does not make any sense. This is wrong. A graph with bridges cannot have a cycle. Now this is completely wrong. So you can have something like this. It has a bridge, but it has cycles also. So this statement is also wrong, and the answer is B.